to another broadcast of MindsYourHealthcast.com. Last week were talking about some observations on anti-aging and longevity, and it's a subject that's been talked about a lot. There's been movies made about it, there's been TV series done about it, and all of those are very interesting. But getting down to the practicalities, what are the facts about it, and can we do anything about it? Now, we're going to give you a lot of information coming from regular research out of medicine, but interestingly, as I've seen in time past, you have all these independent researchers around the country doing different pieces of research, but for some reason they never seem to get brought together very often or synthesized into some type of a bigger picture. Each researcher is so narrowly focused on the one aspect that they're looking at that they don't step back and look at what other researchers are doing and how can this all fit together to form the bigger picture. I would say approach has been over the years to be a synthesizer, which means I take the pieces from various sorts like a jigsaw puzzle and fit them together to form that bigger picture. And many times it's interesting what can be done. I know for years now we've had people with all kinds of terrible health problems, many which were said to be genetic in nature and therefore incurable, or that were said to be incurable because they didn't know what caused it, or that it was too far gone, that the tissue was too damaged or too mutated. And we've seen people get well in spite of all that. And so I formed my own paradigm, my own concept. You've probably heard the word paradigm. Paradigm means a set of boundaries. And generally when true science, and that of course is a joke to me because so many of the people today in the medical field say it's scientific, but yet they don't have scientific principles in the sense that they already start with preconceived limitations on what could be going on or what could be a cause. And it's not just within medicine, it's within the scientific community in general. There are few true scientists. A true scientist is going to look at all the information and go to it with no preconceived idea of what the outcome will be. If you decide that you want to prove that a particular thing is true, and then you gather evidence to support that, of course that is not logic and it's not science. You know, logic says you cannot work on the basis of a fallacy of logic called the fallacy of selected instances. That means if you have an issue, you only pick the people or the information or the studies that tend to support your position, and you ignore all of those that contradict or go against your position. And so if you only select partial instances, then it's not true science. True science says you have to look at all the evidence and then draw your conclusion. But if you go with the preconceived idea, as many of the drug companies do today, they come out with a drug and they realize that there's a huge market potential if they can market it properly. And so they engage some people to do studies about this drug because they have to do that to get the final approval. But then what they do, once all the studies are done, they kind of go through and discard the ones that disagree with it doing what they want to say it does, and then they have this bundle of selected instances that seem to support their position. And of course there's some other maneuvers we mentioned last time, or time before maybe, about the book of How to Lie with Statistics that I suggested that you get and read, and if you have not, I would suggest very strongly that you get it. It's not a big book, but the whole idea is not to use statistics to lie, but to look at a statistical graph or piece of information and determine, is it really saying what they say it is saying? And I mentioned that there's ways you can distort the vertical axis to make something that is a non-event look like a major event. You can look like you stepped in at a time when something was disappearing and intervened and gave some kind of treatment, and then you can elevate the vertical axis and exaggerate the curve and make it look like what you did made some difference in the outcome, when in fact it probably made little difference or none. And so that book, if you read it and study it for a while, will give you some very good information on how to go about looking at things. So, and especially when it comes to medicine, that everything that's put out on the market, you don't want to jump and run and grab until it's had some time to really demonstrate what it does to people. And most people are unaware, and we're going to be doing a session on pharmacology and on the whole concept of drugs, and I think you're going to find it very interesting. But at any rate, the real test of a drug to see what it's going to do to people and what the adverse effects are doesn't always surface until it's out and given to a lot of people. And so when a new drug comes on the market, even though it's been approved to be released and utilized in human treatment, they know that they don't really know a lot about it yet because it was only subjected to very limited human trials. So when it gets out, then that's called the post-release trial. So all those people who rush to get a new drug that's just been released on the market are participating in a study of that drug to see what it really does to people. And many people have terrible adverse events. As I mentioned on one of my broadcasts, there was a drug released on the market for the heart that after it was released on the market, although the pharmaceutical company knew there was a problem, I don't think they knew the magnitude of the problem, so they chose to withhold some negative information, getting back to what I said about selected instances. They withheld some of the information and got it approved to go out on the market, and within a short period of time, 50,000 people dropped dead with it. Now, I don't know what that means to you, but during the 10-year Vietnam War, 50-some thousand Americans were killed over 10 years in that war. So here you're talking in a matter of months, 50,000 people dropped dead. But you didn't hear about it, and hardly anybody has, because it was kept secret, never got into press, and so the drug is still on the market. So that's what I'm talking about, is that you need to weigh the information and learn how to read real statistics. And there's a lot of drugs out there like that. If you read through the PDR, you'll see that there's a special warnings, which there was with the drug I was talking about. There's a warning in there. It says what they call a black letter alert, that excessive mortality has been related to this drug. And I'd say 50,000 people dropping dead is pretty much excessive mortality. But it's still on the market, and the doctor is told, well, you need to weigh the effectiveness and value of it against the dangers of it. But I think if most people knew that there was a high chance that they could just suddenly drop dead, and which is what would happen, the people would be sitting, walking, standing, and just fall over dead when they took it. And no warning, that was it. So what I'm saying is that even if you're looking at the anti-aging stuff, now you're going to get some researchers who come up with something and they say this is why people age, and if we would just take care of that, then the person could live on years beyond the so-called life expectation. At any rate, it's true that that may be a factor, and so that's why I'm calling this observations, because there's a lot of these factors. And I've read books by many, many authors, and they will tell you, oh, this is it, this is the reason you age, and if you just take care of this, you can live on indefinitely. And that's not quite true. And so we started last week talking about some of the various theories of aging, and we're going to continue that today. I know we're going to be running out of time, so we're not going to be able to cover this in depth, but I don't want to stretch it out over 3 broadcasts and make it very difficult to follow, and I'm wanting to keep it enough information that you can get the idea, but without getting it so much in depth that you don't know what's going on, unless you're a biochemist. So we talked before about this average life expectancy, and we need to be clear on that there's a figure that is circulating out there, and every few years the medical people refer to that. And it was a probability mathematical equation that was set up many years ago to not say what do you really live or how long do you really live, but it was set up to say, well, you can expect that you are likely going to live this long. And so they called it the average life expectancy. You can expect to do this, but there's no solid evidence that that's true. It's just that you could expect it. And the reason is there's a type of mathematics called probability mathematics that can give you a likelihood that something could occur. But it's not solid science, it's probability science, which means it's kind of loose. Anyhow, when they first started it, it had people way down. If I recall way back, supposedly a man, the average life expectancy was going to be like 58 or 59, and women in the early 60s, and it's always been that women would live slightly longer than men. And so it was very low, and then every few years they refer back to that and they say, oh well, look what a good job medicine has done, because now your life expectancy for men is 65 and women 68, and then later they come out a few years later and say, well look, now you can expect that the men can live to pushing 70 and the women up into the 70s, and then everybody's saying, wow, modern science is really doing a job. However, when it was set up years ago, in this country there was the 1918 flu epidemic, and so when they took the deaths of that flu epidemic, and we don't have time to cover it in detail, but there's some quirky things about that too. But at any rate, they had this big number that went into this equation, and it takes into consideration a lot of variables, which means it's kind of loose mathematics, because it depends on how many variables you take into consideration. And so if you took all the deaths during a certain period of time, but within that period of time you had 1 million or 2 million people died suddenly because of some epidemic, or 3 million, whatever it ended up, then that's going to skew your mathematics. And so that's what happened. So we had all those deaths from that 1918 flu in this mathematical equation. So the interesting thing about a probability factor is that the longer time goes by after you put that in, the less effect it has, and so therefore it makes it look like you're living longer if you did nothing. And that's all that this equation really means, is that it's a fudge equation that really doesn't mean anything. Because, as I say, every year that goes by, farther from 1918, less effect that amount of people dying suddenly has on the answer to this equation, and therefore it looks like we're probably going to live longer. So it really, to me, has never been very useful, because there was a couple from Harvard, and I did mention that a little bit, but I want this to be clear. As Richard Nixon would say, I want it to be perfectly clear. There is a difference between average life expectancy, which is a probability mathematical equation, and average life span, which means in reality, how long are people living? And so two researchers from Harvard did a big study, went back 200 years, where they could find birth records and death records to actually document what they were working on. And they came up with something called an average lifespan. This meant how long, on the average, did people actually live? Not did they expect to live, but they actually lived. Interestingly, for the last 200 years, the number has been the same. the average lifespan has been 85, which is above this expectancy factor and has been from the beginning above that. So they found out that there were people on the average lived to at least 85, and there were some, of course, that died sooner, either by whatever accident, illness, or you name it, or that lived longer, over 100. So we had people living over 100 way back. So if we're going to talk about really increasing longevity, or the concept of anti-aging, we need to be looking beyond 100 just on the average basis of how long people live. I mean, now they're tracking it more, but you're seeing more and more on TV, these people that are 100, 105, 110, and I think that right at the moment, the oldest documented is about 115. I knew of a guy, actually, that is not in those numbers for some reason, but in real life, out of New York, who died at about 119, and he was healthy and worked every day, wrote books and studied, researched, traveled, up until one night he went to bed and didn't wake up. And there are communities around the world where this takes place, even higher than that. So we have to look beyond that if we're going to talk about real life expectancy. Now, C. Norman Shealy, who's an MD who was known for his stress and pain-related work over the years, has made a comment in one of his books about living beyond 100 that he says right now we should expect to live 140 or 50 if we take care of ourselves. But what would be really nice, and some of the people that have gotten heavily into these studies are indicating that there's no reason why we can't go on almost indefinitely. Now, I personally have the feeling that our mankind's average lifespan at one time, and probably what we could work toward, is probably between 900 and 1,000 years old. So, at any rate, I've, over the years, collected information, watched what was going on, and so these are some of the observations that I have found related to that. Last week, we talked about some of the theories of aging. One was the ROTS theory, reactive oxygen toxic species, which are the oxidation problems in the body. Some people refer to it as body rust. Now, you know, when a piece of iron rusts, it actually is oxidized, and that's what makes it have that powdery, dark brown looking coating that forms on it. When it gets wet or sits out and it has no protective coating on it, it oxidizes and forms rust. So in essence, when something is oxidized, that's kind of what's happening. So your body is rusting if it gets overloaded with free radicals that damages the body because the oxygen is oxidizing or stealing away electrons and changing the tissue and actually causing it to malfunction. So I've read several books, and I've known some people that they were heavy into the ROTS, and some people call it just ROS, reactive oxygen species. But Dr. Bradford, who's a biochemist out of California, he's always referred to it as reactive oxygen toxic species because usually they are toxic in the body. And so having that happen is true. It is true that when your body is being oxidized by free radicals, it's damaging, and when that's occurring, that definitely could help shorten your life. However, that is not the only factor. That is a factor that I have observed can be a problem. It can cause other kinds of health problems too, not just dying prematurely, but causing you various types of health problems related to oxidation damage. The body has repair mechanisms to take care of that, but a lot of it depends on what you eat. You have to eat the right food, and in today's world, in most cases, you're going to have to take supplementation because the food is missing a lot of the nutrients and factors that are needed to make this work. So this is something that can be taken care of by taking care of your body and feeding it properly, because definitely longevity is going to depend on how much of the right thing you have in the body for it to work with to carry out what it can do. And there are several protective mechanisms in the body if you have the right nutrients to help the body do that. So rots we mentioned, and the other big one, of course, is membrane defects, and that kind of goes with oxidation too, but it can go also with diet, and it could go with radiation damage. And we certainly have a tremendous amount of radiation exposure today that people haven't had before. A tremendous amount of diagnostic procedures used in medicine engage the use of radioactivity. And every time you're shot with an X-ray, you're being exposed to ionizing radiation, which can damage internal factors of the cell, including the DNA, and it can also damage the cell membrane because of it dislodging electrons. And in a sense, it's kind of like the oxidation problem. You damage the membrane, it doesn't work right, you don't take in the nutrients properly, you don't keep the poisons out properly, or you don't empty out the poisons properly. So it can create a lot of factors. So it is true that membrane defects are a problem, and again, it could be a down the road shortening of your life problem. But it's not the only reason why you are going to age. It's just one of a group of factors that need to be addressed. Now, interestingly, you will find that the same thing that helps some of these are going to be helping the other things too. Because in all these cases, it's going to require that you have the right nutrients in your body. And I know that people, many of today at least, are adverse to nutrients that you take, like food supplements, vitamins, minerals, amino acids, fatty acids, all those things that we end up taking, or at least some people do. And some people don't like to be bothered with it. They think it's a waste of time. But I know that the Department of Agriculture has tested the food over the years, and it's been known that clear back to the 30s, there was already deficiency of minerals from the soil because they were being depleted then. And there was a paper read before Congress which was actually printed up about miracle doctors, and the miracle doctors were some of the doctors way back then who realized that this mineral problem of being depleted from the food was a big problem, and they started supplementing minerals in their treatment of their patients and had a lot of bad health problems turn around by supplementing. And so this researcher presented this information to the U.S. Congress in a speech saying this is a problem. Well, that was in the 30s. Now here we are in 2012, and it's still a problem, except worse, because as you commercially deplete the land and you don't replace it, eventually there's nothing there. Now, sometimes they'll throw a couple, 3 key minerals in because they have to grow the plant and it has to look like food, even though it may not be food, it needs to look like food. And so they may throw 2 or 3 minerals in that are necessary for it to grow and look like a tomato or a pepper or whatever it is. But that doesn't mean that there's any nutrients in it. And even organic, we've mentioned before, but I want to emphasize again, because the product says certified organically grown, just remember that has to do with the method of growing, not with the quality of the soil that it's grown in. So as long as they don't use pesticides and herbicides and artificial fertilizers to grow, they can call it organic, which is true, but it is organically grown. It is not organically nourished, which means if the soil doesn't have it, it's not going to be there. So it looks very pretty, and I'm sure some of you by now have bought a certified organic piece of fruit or vegetable and bit into it and said, yuck, it tastes like fiber with some coloring in it. Well, it's true, but it wasn't the organic growing process that's the problem. The problem was the soil they grew it in. So if you go to depleted soil and use proper growing method, you're still going to have a product that is depleted in nutrients. So you really are going to have to supplement in some way. And so I'm saying that some of these things that we're talking about, the very thing that is going to help that to not happen is that getting the proper nutrients in your body. And they're not going to be there if you don't put them there, and if they're not in the food, you're going to have to supplement them otherwise. And I know it's a real pain in the neck or otherwise to have to take the things, but if you don't take them, you definitely are going to become deficient. So you're talking almost like deficiency diseases, which is not very good. So I'm saying that a lot of this can be resolved, and of course I know that's what you're going to want to know. What can we do to live longer? And there's a lot of books and information, and each of these things we've mentioned, that the person who is saying this is the problem, they're telling you what you could be doing to help that problem. But when you start looking at the big picture, you begin to see we're talking about deficiencies. So if your body has deficiencies, it's going to have a problem in not only not living long, but you're going to have a lot of health problems in between. And that was really what brought up this whole idea of nutrients when the men years ago were on sailing vessels and eating garbage a lot of the time and not getting fresh fruits and vegetables. They developed deficiency diseases, and that's where the first information kind of came to the foreground about how important nutrients in food were. So you couldn't eat some old dried beef jerky for weeks or months and no vegetables or fruits without becoming deficient in some of the nutrients that would be in the vegetables and fruits. And so they started having to carry that with them to keep the crew from getting sick because of deficiencies. So at any rate, that's going to help the problem with ROTS, because when you eat the proper food or take supplements, you're going to have antioxidants, which are going to offset the ROTS problem. They're also going to offset the membrane defect problem. Now another third one that has become really big, and I should mention one more thing about the membrane I didn't mention, is that the membrane is made up of fatty acids, which is a major player, and if you don't have those fatty acids, you cannot make a healthy membrane. So it's important that you do that you have the right fatty acids, which means not the polyunsaturated oils that they've been pushing for years, and we kind of covered that pretty heavy when we talked about the cholesterol issue. We have to have fatty acids to live. The Nazis found out that if they deprived prisoners for 90 days of no fatty acids whatsoever in their diet, that they would begin to die off, and nobody would know why they were dying because they were feeding them something. What they did is they boiled potatoes in water and gave that to them to eat, but they gave them absolutely no fatty acids. And after a while, the membranes begin to deteriorate and cannot rebuild, and that means the cells can't function properly, including the brain. And so pretty soon you've got a problem. So there's another case where the proper nutrients are important, and if you're not getting it in your food, you definitely are going to have to supplement. So the next biggie that a lot of people have argued is the real reason that we age is the mitochondrial problem. You know, the mitochondria in the cells are the organelles that produce energy. And for anything to happen in the body, you need energy. And so the body has provided a means to do that, and it's done with mitochondria, which is where, if you've read much of anything about the body or biochemistry, you've heard of the citric acid cycle or the Krebs cycle, which is the series of biochemic steps that take certain vitamin mineral factors and produce energy from it. And that includes the respiratory chain and so forth. So the mitochondria have to be functioning well and building these storage batteries of energy to make your body work. Every time you move an arm, the muscles that are involved in moving that arm require energy. And that energy is provided by small molecules called ATP, which is adenosine triphosphate, and those are called also high energy phosphate bonds that are holding energy so that when you need it, your body can call on that to carry out the various things it needs to carry out. And of course, without energy, the body does not live, it dies. So having a lot of energy is a major factor in longevity. So the mitochondria have to work properly, but unfortunately, we do so many things today that will interfere with the production of energy within the cells. One, of course, gets back to what we were just talking about, is deficiency. There's certain key nutrients that are required to make the Krebs cycle and the respiratory chain work properly in order to make the energy. If we don't have those, it cannot work. And if we're missing one step in the process, then the process is not going to work and it's not going to produce energy. So you have to make sure you have proper nutrients. I know riboflavin is one of the big factors, which is B2, and magnesium and zinc, and some of these key elemental factors are necessary to make it work. And if we don't have those, if we're deficient, this is not going to happen. So, and on top of it, if it becomes less efficient, it also produces a lot of free radicals. So then we get back to the earlier problem we were talking about. There's free radicals produced, and you need something to take care of those. Now, two of the big things that are extremely important for the cell to function properly and to make energy properly is iodine and selenium in the form of selenomethionine. However, the soil is depleted pretty much all over now with selenium, and the food therefore doesn't have it in it. So many people are deficient in iodine and selenium. And without those, you cannot make proper energy, and a good indicator of that is if your body is running low body temperature-wise. And I started a few years ago in the clinic. Every patient came in, and every visit, one of the things that we measured was their temperature, and consistently everyone was running a degree or more low in temperature. Instead of 98.6, they might be running 97.6, or they might be running all the way down to 97, and in some cases 96 something. Now that means that the body is not producing energy, it's being shut down. And when the body temperature drops, then a lot of processes in the body cannot work like they should, because most of the processes that take place in our body require enzymes to make those processes happen with some speed. And those enzymes are sensitive to three major things, which we've mentioned before. And I keep throwing these things in because I still want to anchor it in your mind and lock it together. Enzymes to work properly require the right amount of moisture, which means water, and it requires the right amount of temperature, and it requires the right pH. And those three things are necessary for an enzyme to work properly. So if you don't have the right temperature, even if you have the right pH and you have enough water, but you don't have the right temperature, you get a malfunction. It doesn't work as well as it should. Or if you're dehydrated. So those become important factors in anti-aging, is that you are hydrated. And that also, dehydration is one of the reasons why you're going to age. There's some people who have studied water very heavily and have indicated that a lot of hospital deaths in the elderly occur because of dehydration. They put them in the hospital, they put them in bed, and they bring water every day, and they've got a helper that comes in and changes the water, and if the person drink all of it or none of it, nobody knows. And so the person lays in the bed, dehydrates, and suddenly the body shuts down and they die. And this one researcher is convinced that a very high percentage of hospital deaths of the elderly are caused by dehydration. Just didn't get enough water, and nobody was in charge of making sure they were drinking water. And of course, there are ways you could test it, but that takes time, and most hospital staffs are overworked as it is, and they don't have time, and most of them don't even know about it anyhow. So how to do it? But there is a way to test it very rapidly. Is the body being dehydrated in general, and how about inside versus outside the cell? If the inside of the cell is dehydrated, then it doesn't work right. If the nucleus doesn't have enough hydration, the DNA actually twists a different way and forms a different configuration, which means it won't replicate. Therefore, your cell will not build new cells when it needs to, and it won't code for the proteins that are needed to make enzymes and hormones and more tissue in the body. That can't happen either if the configuration shifts in the DNA, and it actually will twist in the opposite direction if it becomes dehydrated, and it won't work. So dehydration can be a major issue, and it would be one of those things, because I'm putting it all together because I'm trying to show you how all this stuff interplays with each other, and you can't pick any one and say, yep, this is it. That's why you age. Or if we take care of that, then you should live for 200 years. That doesn't work that way. Everything in the body is all interconnected, and so even though people have picked out these particular things and said, now this is the reason, it's not the reason, it's a part of the reason. And many times it's only a symptom and not a cause. And so when the mitochondria aren't working right, there's other things that are going on why that mitochondria doesn't work right. And of course another big factor, again getting back to toxicity, which we keep talking about over and over in our various lectures that we give, is that toxicity interferes, certain types of chemicals will interfere with functions in the body, and in particular the mitochondria is sensitive to some of those things. For example, there's certain antibiotics that will shut down the respiratory chain. There's certain anesthetics will do it. People don't ever hear about it because they don't propagate it, but there is a type of death that can occur when they do a surgical procedure called malignant hyperthermia. Now what that means is that that particular person, what they were using for the anesthetic blocked the respiratory chain and shut it down. Now when it blocks it, what happens is that instead of making ATP molecules for energy, it just produces heat. And so the body starts getting hotter and hotter and hotter until the person expires. They literally burn themselves to death because they can't shut down the chain totally, and it keeps pumping out heat. And people who do anesthesia know about it, but you're never going to see, at least I don't know that I've ever seen any place, that the cause of death was malignant hyperthermia. Now they know about it, but it's not something they talk about to the public. So at any time, a person could be doing a surgical procedure and the anesthetic could shut down the mitochondria and they could literally burn themselves up and die. So usually they would say cause of death due to complications of surgery, but they're not going to say, yeah, well, the anesthetic did it. It actually shut down their mitochondria and burned their body up. So those things can interfere, but there's other drugs and certain pesticides that can shut down all or part of the respiratory chain, and of course certain organic chemicals that can really do it. And one, of course, is cyanide. I'm sure everyone's heard of cyanide poisoning they use in the gas chambers. Cyanide totally shuts down the respiratory chain and the people expire. If you can't make any energy at all, then you're done. And that's what it does. It blocks that. And then, of course, there's another thing can happen. If you shut off the oxygen supply to the mitochondria, you can't make energy either, because a properly functioning mitochondrial organelle requires pure oxygen as part of the process to make energy. So it puts certain key nutrients, electrons and protons, and oxygen into the respiratory chain Krebs cycle, and out comes two things, or three things really. Energy in the form of ATP molecules, and the other thing that comes out is carbon dioxide and pure water. And that's what happens when you make energy. Then the body can utilize the pure water, or if it has enough, it can empty it out through the kidneys, of course, if you have too much. The carbon dioxide goes back out of the cell, goes into the blood, goes back to the lungs, and is blowing out through the lungs. And so your body is not poisoned when it's working properly and it's getting the proper things to use. Now, on the other hand, if you block up this chain, either the respiratory chain or the Krebs cycle, one or more steps, you actually can produce some toxic byproducts, you can produce some free radicals, and so there's other factors in the cell that can take care of that if you're not deficient in it. So there's so many things that happen that all have to do with deficiency. And getting back to what we said earlier, that one of the key players in living long is to have the proper nutrients so your body can function properly. And so mitochondria is a problem, but it's not the only problem. It's one of several things that become disturbed when the body does not have proper nutrients or it's intoxicated. which just brings us back to the next thing, which many people say the real cause of aging is body toxicity. Over time, you keep building up more and more poisons until finally you die from self-poisoning or auto-poisoning because your body didn't get rid of it. Now, the body, if it's working properly and it's not being overwhelmed with poison, will take care of getting rid of those toxins. But if it's not working right, if something has happened, then it can't clean it out, or if it's just totally overloaded, which can happen. And in our society is more likely to happen than not, because everything that we touch anymore has either pesticides, herbicides, some type of organic dye or organic preservative, or something that is going to contaminate the food that your body needs to get rid of. And in order to get rid of it, all the parts have to be working right. The mitochondria have to be working right. The membranes have to be working right in the cells. And the lymph has to be functioning. And the immune system has to be functioning. In other words, all these things have to be working together to allow the body to detox it out, including your lungs, which actually most people don't think of it. You know, there's certain routes that the body gets rid of things. We've talked about them before, but we'll emphasize it again. One is the urine, of course, and the other is the bowel. So those are the two biggies that we know, that a lot of things that the body's getting rid of come out through those areas. But then we also have the mucous membranes. And the mucous membranes, actually, if they get a lot of toxins, they will start putting out mucus. And the mucus is a way of your body flushing the poisons out of the body. And, of course, the skin. If the body can't get rid of things other way, it's going to come out through the skin. So we get all these kind of skin problems. And how do we treat it? Well, we either give people antibiotics or we put some kind of creams like steroids and so forth on the surface to push it back in. So what we're doing is we're poisoning the body further by doing that. But, of course, they look nice by pushing it in, but they get sick. And, of course, I think it's Accutane was the big one that was out for quite a while. It was one of the drugs for acne. And now, of course, there's a group of attorneys that are handling cases of the people who are damaged by taking the Accutane. So when you push the poison back in, what you do is it's going to settle someplace in the body, and so wherever the weakest organ is, usually that's where it settles. And so you poison the body internally if you don't let it get out through the skin because the body is trying to get it out. Or you have to open up the detox pathways in the body so it can work properly. So, I mean, these all play together, and so, as I say, I kind of smile when I read a book that says, now here's the reason you age. If you just take care of this, then you're going to be fine. Well, that's not true. You're going to have to take care of all the things that we've been talking about right along. I'm just now emphasizing how each of these factors are a part of that, but it's really a part of living a healthy lifestyle, period. Now, the body has to get rid of all this stuff. And I didn't tell you, I started to tell you about the lung. I want to tell you that before we're done. The lungs actually get rid of the bulk of the poisons in the body if it can be made into a volatile, like a gas or something that evaporates out. It will come out through the lungs. So actually, if you study detoxification of the body, the lungs will get rid of more poisons than anything else. It does blow off carbon dioxide, which we just talked about, but a lot of other things that you get in your body will come out through the breath as you exhale out, and that's how the body can get rid of it. So even though most people think maybe the skin is probably the biggest detoxer, it actually is the lungs above everything else, because a high percentage of it can be blown out with the lungs even before it has to go out through bowel, kidney, or skin. And, of course, all this assumes that the lymph, as I say, is working right. In so many cases, it's not. But the type of things that we pick up, I pretty much mentioned, except I didn't mention that there are metabolic byproducts like carbon dioxide and so forth that your body needs to get rid of. And if you pick up things like a virus, then when your body neutralizes the virus, it has to get rid of those things that are left over from that. And usually if it's a virus, like a flu virus, it hits the mucous membrane, then you have the runny nose or you have the mucus coming from your lungs, Everybody thinks that's bad, so immediately they start drugs to stop it, and of course they lock it in. So then down the road, what do you a good candidate for? You're a good candidate for lung cancer, for sinus cancer. In fact, I had an aunt that died of cancer of one of her sinuses because over the years they kept giving her antibiotics and steroids because of having these sinus flare-ups, and finally it ended up she developed a massive tumor inside the sinus cavity, and they started cutting away at surgery and chopping her up, and she lasted, I think, about a year and a half or something, because eventually it spread into her brain, and that was the end of it. But only to say, the body needs to get the stuff out, and those are the methods that the body uses to get it out, and if you interfere with any of those, I know having a runny nose when you're getting rid of something from a cold or a flu isn't fun, but it's not good to stay in there either. That's why the body is trying to get it out, or it is getting it out if we don't stop it. Now, it's interesting because in order to do that, the body has to bring white cells, and it has to bring blood and nutrients into that area wherever that virus was to get the garbage out from the virus. Well, interestingly, it's uncomfortable because remember the symptoms of inflammation are redness, heat, swelling, and pain. So that means that the mucous membrane gets red, inflamed, and swells up, and it can hurt. Sometimes, not always, but it can. If it's pressing on any kind of sensory nerves, it can hurt. So at any rate, what does medicine do for you? Well, they give you a decongestant. And what does a decongestant do? A decongestant constricts the blood vessels so that your body can't bring nutrients and it can't bring blood into the area, and therefore the swelling goes down. And they give you an antihistamine, which turns off part of the white cells that provoke that response of bringing the white cells and the blood into the area so that the body can take care of it. So what you do is you stop the immune process and you lock whatever the poison is that the body was trying to get rid of, you lock it in. So as time goes on, you end up with a big problem. So those are things that can be toxic to the body, and your body normally wants to get rid of it, but if you won't allow it, then of course that's a big problem. So when we're talking toxicity, we're talking about auto-intoxication, or those things that come from your own body metabolism or from fighting things. When a white cell actually forms an antibody and decommissions like a virus or whatever, then a signal goes to the phagocytes to come in and digest all of that. So now you have toxic debris left over from that, because you also usually have either hydrogen peroxide formed to denature the virus, to oxidize it, and then it gets digested with the phagocytes. But sometimes it's such an overload that they die off, so then your body needs to get rid of those out. And if you stop that whole process, as I say, you lock all that in. And so there's all these things that we get from our environment, whether they're organic, whether they're medications, antibiotics, all of these things add to the toxicity. And as your body becomes more and more toxic, it's not going to live as long because it's going to interfere with the various factors in terms of it working right. Now, the other thing I mentioned a little bit before, again, about toxins, because this is a different type, was the radioactivity and electromagnetic fields. They can shut down things in the body, so you have to make sure you're not being exposed to or getting overdoses of radiation. And when it comes to X-ray, it appears that there really isn't any safe dose because it accumulates in the body, and the average person, every time they get an X-ray, they've added to their toxic load of disturbance from electromagnetic factors. And of course then, if you do the radioactive nucleotides for a heart test, then you're putting radioactivity in. If you do a PET scan, you're putting radioactivity in. So there's a lot of tests that medicine uses that uses these isotopes that are radioactive, and of course they don't just disappear out of the body rapidly, they hang on. And some of the therapies they use, of course, like for cancer and so forth, they use a lot of either strong X-ray or other types of radiation. And so that's going to be a big problem. So I'm telling you all that to say that we always should keep any of those things to a minimum, and I don't advocate any such thing as routine X-rays. In my opinion, whether it's mammograms or whether it's routine chest x-rays or routine dental x-rays, you should not take any of that because it causes a lot of problems in the body, and it's again not immediately apparent. I think the worst thing about chronic illnesses are that we don't know that it's happening until it's a crisis. Meaning, almost always, as we've said before, most chronic illnesses have their beginning 20 to 30 years ago. So there's something starts it, and then we keep adding to it, and we don't realize it, and we're not feeling it. And the more we get toxic, the more that the immune system is impaired. The more the immune system is impaired, the less symptoms we have. The less symptoms we have, we actually deceive ourselves into thinking that we're healthy because we don't ever get a cold or flu. And it's still such a misnomer about that, is that when you get a cold or a flu, number one, you don't know that you got it to begin with. It's there for at least 3 days, replicating and doing what it does in the body, and is being blown out and passed on to other people. And it's only after about 3 days that all this viral activity is over, and now the body goes into cleanup mode. That's when people think they get the flu. And the cleanup mode is not the flu. The cleanup mode is exactly what it is. The cleanup mode is producing mucus. That's when you get the redness, heat, swelling, and pain of the mucous membrane. Your nose starts dripping, your eyes are watering, and all this is going on. You're coughing and sneezing and whatever it is, fever. That's when your body's getting rid of the debris that's already been neutralized by the immune system. Now, if your immune system isn't working, none of that happens. So guess what? You think, well, I never get a flu. Well, you have. It's just that your body didn't respond to it, and it didn't get rid of it because it's not working. So you can go for years and think you're really healthy, and then all of a sudden one day you find your body's full of cancer. Well, it didn't just happen. That's because it built up over time, and now it's finally reached a critical stage. And that means you've poisoned the body so much that you've shut down cells. The cell now disengages, becomes a mutant cell, and grows into a cancer or tumor. But it was happening from way back. That's why you don't just suddenly get a cancer. It's been in process for years and years. And finally it reaches critical mass. Now you know you have it. Now you've got a big problem. And the body is so disturbed, the immune system is so disturbed. Then they put you on chemotherapy, and the chemotherapy, of course, finishes wiping out the immune system, which guarantees that if you have the chemotherapy, you're going to have a return, because it's, number one, it's never gone to begin with, because you can't kill every cancer cell even with chemotherapy, and only one cell left can grow into tumors again. So you're in big trouble, especially if the immune system can't stop it. Now, I know you know we've been told that the immune system, we form bad cells and the immune system takes care of it, which is true. But if you have the immune system shut down, it can't do that. And so you just are going to be assured that the chances are about 98 to 99% that you're going to have a return of that malignancy. It's just a matter of when. And many times it's not detected for a long time, and so then you got a problem. So what we want to do is, as always, our time is running short. We want to mention a couple more things, and then the same things that are going to work with each of these things are going to be powerful in terms of anti-aging. And as I say, the biggies are going to be the nutrients and detoxing the body. And the other biggie is going to be your emotional side, the amount of stress you have and how you cope with it, and also epigenetics, what you bring down from your family that's not in the genes, but attitudes and imprinted information that you get from your ancestry that can say, oh, well, all of our people die at age 46 or 52, or all of our men die at such and such age. Those can all be a major factor in anti-aging, is to get rid of those pieces of information that are detrimental, and also our own personal expectation that we've developed, that we think that we're going to die, or we get obsessed that we're going to die if we aren't careful, and intend. Sometimes people really do, whether consciously or unconsciously, intend to expire, and they do. And I've watched it happen over the years with people who decided that they were going to die, and they did, and sometimes within a few days. And of course, many people have seen it when a mate dies and the other person just doesn't want to live anymore, and within a day or two, they will join the other person by expiring also. So those are big factors. So as far as the factors for aging, there's some other unusual things. We're not even going to get into it now, but somewhere down the road we may mention it. But there's probably some ways that we can really regain that ability, as I said, to maybe last 1,000, pushing 1,000 years. And at some point when I feel that we're at a point we can really get into that, we will talk about that a little bit as some of the very advanced things that could be done. Now, I've mentioned the stress, which is really one of the things that makes it worse in terms of aging, because it stresses the body. When you are stressed emotionally from your environment or your own thinking, it stresses your body. It produces too much cortisol. It upsets the DNA production, or DHEA production, I'm sorry, and therefore the body pays the toll. It beats up everything, beats up the brain, beats up the organs, it beats up the lining of the arteries and so forth. So that's a big problem. But the one other thing I did want to mention was the telomeres in the DNA, because the DNA is one of the other problems. Either it's damaged by oxidizers, which are free radicals, which it can happen, or it can be damaged by electromagnetics, such as an X-ray and radioactivity. But it also can have another problem with the DNA, and that is at the end of every strand of DNA, on the ends are special molecules called, I call them telomers, some people call them telomeres, but they're a group of molecules that keep the DNA intact and working properly. And so when you replicate the DNA, it uses up some of the molecules in that process, and after you've used it down to a certain point, the cell becomes inert, meaning it can't replicate anymore. Now, there's a researcher, Dr. Hayflick, that did a lot of studies, and he determined that a human cell only has about 50 replications before it becomes kaput. It doesn't replicate anymore. But he wasn't into the telomeres, but now later then people got into the telomeres, or the telomers, and they realized that that is a problem, because they could observe that when they came down to the end, then it's like the DNA just goes, and that's it. It's not going to do anything anymore. And so they're looking at ways to fix it. Well, I mentioned earlier that there was a lady by the name of Henrietta Lacks, which was a lady that had cancer, and doctors took several of her cancer cells and preserved them. And what they found out is that over the years, they just kept replicating. And so the cancer cells did not follow the Hayflick limit idea. These were human cancer cells, but they did not follow the Hayflick limit. And so consequently, as they got into the telomere thing, then that appears that might be what is happening, that limits how many times it can replicate. Now, interestingly, we have a gene that can make telomerase, which is an enzyme that puts the telomeres back on. For some reason, the cancer uncaps that gene, makes telomerase, and it can just keep replicating and replicating indefinitely. So instead of 50 times, it could go 100,000 or 1,000,000 times or whatever. And so that's why they wrote this book, The Immortal Life of Henrietta Lacks' her cancer cells. They just go on and on and on. So now there's been a lot of research in how can you increase the telomerase or telomerase in the cells, or how could you uncap the gene. So there's been a lot of research in that, and there is one product on the market that's you can join and become a part of getting it and taking it. Not cheap. Of course, the people who developed it to make money, and they thought they've got a winner. And it's called TA65. It's a isolated fraction from astragalus, which is a Chinese herb that's known to have a lot of good qualities in the body to help the immune system and to help you deal with stress in the environment. It's called an adaptogen. And so they've taken this one factor and patented it, that they've developed a process to take it, and they put it in capsule form, and you can buy those capsules for several $100s per bottle of 60. And you can get in this project if you want, and they've been studying it to demonstrate that it does help. There's some other people have come up with some other more natural things that they think are going to work equally well. And I guess it's wait and see on those, but I've looked at some of the things, and I'm thinking that there's, apart from some of the more advanced stuff that I said we're not going to talk about today, I think there's some other ways that we can deal with it in terms of helping the body neutralize the loss of the telomeres, and therefore to keep the body going. Now, one of those is going to be the mental state. So we're going to be talking more about that, all the things that we can do for our health that have to do with our way of thinking and our attitudes about ourselves and about everything out there, and also our intent as far as what we want to do. So we're going to get heavy into the psychoneuroendocrinoimmunology. And understand how much effect we really do have on our own body systems and what we can really do to live longer. And as I said, one of them is the intent to live longer. And if you have that, that's going to go a long way in helping to make changes in the body. But then you also have to put in the things that we talked about, like getting in the right nutrients and helping your body to detox out. And we didn't go heavy into the detoxing again. We've done it quite a bit, but just remembering that things that they come out of the cell, or if they get into the body and they're extremely toxic, they do not go through the blood, they go through the lymph system. And if they're moderately toxic, they go through the regular lymph system. If they're very toxic, they go through the RES system, which is a reticuloendothelial system, which handles the real heavy poisons. The body will not let those in the blood. They have to go through these other systems first to be detoxed before they can get into the blood. Otherwise, you would have blood sepsis, and then you would go into a high fever and shock, and it can be fatal. So the body always is protecting itself, has backup systems, if it has the things to work with, getting back to if it's not deficient and all the things we need to work properly. So those are important things in terms of anti-aging. There's ways to measure how fast you're aging. I think one of the best is body composition analysis, which has the capability of measuring things like phase angle that tells you how fast your cells are dying off, parallel capacitance that tells you how well you're able to maintain a membrane potential, getting back to the membranes. It can tell you also about the hydration factor, total body water, intracellular, extracellular water, all extremely important factors for living healthy, period, let alone living long, but is a good measure if those are not right. We didn't have time to really get into nitric oxide, but nitric oxide is coming up to be a major player, not only in maintaining blood pressure properly and killing off, because it can be used by white cells to kill off cancer cells. By injecting them with nitric oxide, it will kill them off. And that's a natural process from the natural killer cells if your body's working right. But it also is important, it appears, for longevity. And there's some big studies now about the nitric acid amount that we have, and there's things that we can do nutritionally to improve that. There is a test now, a saliva test, that you can test to indicate if you may be really deficient in nitric oxide. As I say, it's actually ended up being a neuromessenger, like any of the other transmitters, the neurotransmitters in the brain and the body. Then it's like a neurotransmitter of a sort, and it can cause the blood vessels to relax, and if you have a proper level of it, you don't get hypertension. So deficiency in certain things that might cause a deficiency in nitric oxide can be a big problem. So I think I've given you enough to kind of wrestle with. If you look at our site, there'll be some books on there that you can read by some various authors that you can look more into it. There's one on nitric oxide. There's some on the mitochondria. There's going to be a lot on the free radicals, and a lot on the DNA and the telomerase. all of that is being written about. And as I say, no one of them is the factor. It's a combination of giving the body what it needs, keeping it clean of the things it doesn't need, and keeping your head clean in terms of your thinking and your ability to deal with stress and your intent, if you really want to live long. Now, I've heard people say, I don't want to live too long, there's too many problems in this world, and I'll be happy when I get out of here. Well, if that's the case, then this is not good for you. And I mean, it won't be a problem, because if you have that attitude, that's right, you'll get out of here. Although sometimes it doesn't work, because consciously you may be saying that, but unconsciously there's that will to hang on. And I've seen that happen, where I had one patient who, I've seen her for years. Her husband died years ago, and she continues to say, I want to join my husband, I'm ready to die, I want to get out of here. And she's been saying that for the last 10 or 15 years, and she's still going. So I'm sure that consciously she may be thinking that, but I think on an unconscious level, like most people, they want to hang around as long as possible. As I've said before, I'm not afraid to die, but I'm not in any hurry. So I'm ready to hang around a long time, and to me it's fun. There's a lot out there to learn, a lot of things to do, and every day is an exciting day if you make it that way, and that's part of the attitude you need if you want to be healthy and if you also want to live long. Don't forget to tell other people about our broadcasts, and don't forget to monitor our website, mindyourhealthcast.com. We're constantly putting things in there, new books, new pieces of equipment, new things related, light sound machines, all these things that can help you improve your health status and, of course, ultimately to live longer. It was nice to be with you again. We'll see if we can dredge up some exciting subject for our next broadcast. And of course, if you look at regular science, you know, or regular medicine, which is, I think, they're pseudoscience, they would be saying it's all quackery, but it really isn't, in my mind. And it's up to you to decide in your mind what you think. It was nice to be with you again. Until next time, be healthy.